Hello, welcome back to my YouTube channel. If today is your first time joining us, this is Learn with Maki channel. So in this lesson of basic mechanics, we will talk about the parallelogram law and the triangle laws. The parallelogram law. About the parallelogram law, these are some points that we have to notice. The sum of two vectors is equal to the diagonal of the parallelogram formed by those two vectors, mathematically giving us a plus b equal to r. Resultant vector is that vector whose total effect is the same as the individual vectors in magnitude and direction. So we said that vectors have magnitude and direction. Now let's consider this example. Let's say I have a vector A, and vector A is represented as this, and I have another vector B, and vector B is represented like this. So in these two vectors, we see they both have one, the magnitude, and then they also have their direction, which is an angle here. The angle here describes the direction. In the same way, the angle here describes the direction of vector B. Now, you realize that if I should draw vectors A and B on the same plane, I'm going to get something like this. Let's say I have the same plane here. I have the plane is here. Then I have vector A drawn here. And I have vector B also drawn here. So this is vector A, this is vector B. Now I have put both vector A and B on the same plane. After drawing this, we can conclude at something. Now let's draw another parallel line to vector A. Starting from here, we are drawing a parallel line. So we are getting a parallel line like this. Then let's draw another parallel line to vector B at the other side, which will look like this. So the parallel line will look like this. Okay, let me put the direction here. Then let me put that direction also here. So in other words, I've reproduced vector E at this side, and I have reproduced vector B at the other side. So if we look at this completed diagram or completed shape very carefully, we can say that this shape represents a parallelogram. So this whole shape represents a parallelogram because one, the vector here at B and the one reproduced here are parallel. In the same way, the vector A and this vector here, which has been reproduced as a reflection of A, they are also parallel. So since the two sides are all equal and parallel, then we can say this particular shape represents a parallelogram. Then after representing it with a parallelogram, what's next? Let's draw the diagonal from one side to the other side like this. So the diagonal of this parallelogram from here to this point, let's call the diagonal R. So what can we say about this? What we can say about this is that according to the parallelogram law, okay, if I have two vectors, that is vector A and then vector B, and if I am able to represent those two vectors, which is vector A and vector B, by two sides of a parallelogram, as in this one, the first vector A represents one side of a parallelogram, vector B represents the other side of the parallelogram, and I completed it to complete the parallelogram. Now, if I'm able to represent two vectors by two sides of a parallelogram, then the diagonal of that parallelogram, which is the R in this case, represents the resultant of the parallelogram or the resultant of the vector. So mathematically, we may say that vector A plus vector B is equal to R, where A is a vector, B is a vector, then R is the resultant of those vectors. What is a resultant? When we say a resultant vector is a vector whose magnitude, or let's say whose effect, is equal to the sum of the two other vectors. So I have vector A and vector B. If I should add vector A and vector B, the total effect or the net effect that vector A and vector B are going to give me, that is what is represented by the resultant R. Okay, in another example, let's say I have a vector, say vector K, and then another vector here, let's call this one vector M. What's next? Let's put vector K and vector M on the same plane like this. Assume this is the plane. Now I have vector K moving this direction. I have vector M moving the other direction to M and then K. So if I should assume that the vector K and vector M, they represent two sides of a parallelogram, then it means I can complete this whole diagram, or let's say I can complete vector K and vector M as the sides of a parallelogram like this. So let me draw the imaginary line parallel to vector K, then another line parallel to M like this, parallel to M. Now, after completing this, I have a parallelogram. If I should join, or let's say I should draw the diagonal from one end to the other, I'm going to get something like this. And this diagonal here is vector R. R means the resultant vector. So basically, this is what the parallelogram law is saying. If I have two vectors and I can represent those two vectors by two sides of a parallelogram, then the diagonal of that parallelogram those two vectors are representing, in both in magnitude and direction, is the resultant of those two vectors. So that is the parallelogram law. In another scenario, let's say I have a vector. Always remember, vectors has a vector has both magnitude, direction, line of action of the force, and then the point of application. Okay, so this vector here, assuming it's facing this side. Let's name this vector x, and then I have another vector here. Let me call this vector y. So the parallelogram law, if I should put these two vectors together, which is the first step. So step one, I am putting the two vectors together to look like this. Let me draw one plane for them. Then I draw the first vector here, which is x, vector x. Then I draw the other vector here, which is vector y. Now these two vectors have been represented by two sides of a parallelogram. So if I should complete the parallelogram by like this, and then the other side too like this, then I draw the diagonal, a line passing through the diagonal. That line passing through the diagonal is my resultant r, and that resultant r in magnitude and direction is the resultant for these two vectors x and y here. So it doesn't really matter where or how the vectors are being arranged. If you're able to put them together, they definitely, if you put two vectors together, definitely they will represent two sides of a parallelogram. And the most important thing is that you complete the parallelogram, you identify the diagonal, and then that diagonal is the resultant of the parallelogram. Assume I have two vectors, vector A and then another vector here, vector B. If I am able to represent two vectors, vector A and vector B, by two sides of a triangle following a particular sense, then the third side which completes the triangle is the resultant of the two vectors. That is to say, if I put vectors A and B together to look something like this, this is B, this is A, this is vector A. So we see that vector B and vector A, they are following a particular order. That is, they follow a particular sense. So if I complete these two vectors to form a triangle in this, so assume that the third side of that triangle is this. So the third side, which is completing the triangle, is the resultant of the triangle. If two vectors can be represented by two sides of a triangle following a particular sense, then the third side of that vector, the third side which completes the triangle, is the resultant of the two vectors. So how is the parallelogram law different from the triangle law? The parallelogram law and the triangle law are very much alike. They are very similar and they can be used quite interchangeably. So let's say I have these two vectors. According to the parallelogram law, I have to represent the two vectors by two sides of a parallelogram. Then the diagonal of that parallelogram is the resultant of the two vectors. follows the triangle law, I represent the two sides or the two vectors by two sides of a triangle. So in a typical example, in the examples given, that is in the vectors given, vectors A and B, if I put them together per the parallelogram law, it's going to look like this. So one, I'm going to have vector A here, then I will get vector B here. According to the parallelogram law, I should complete this parallelogram. Then the diagonal here is the resultant. So if I look at this particular shape carefully, then I see that if I divide it into two halves, if this parallelogram here is divided into two, I'm getting two triangles which are put together. And mind you, considering the lower part here, the lower part of this parallelogram, we realize that we have triangle A, B, and R. And triangle A, B, and R, A and B, or let's say B and A, they are following a particular sense. That is this way. It goes here and it passes here. So this is the sense that they are following. So if we look at triangles, triangle A, B, and R, we see that it is the same triangle represented here as the triangle law. So we can say that two of the triangle laws come together to form the parallelogram law, in the sense that vector B follows vector A, and the resultant also follows the other part, which is the same as it has been described in this triangle per the triangle law. The two vectors must follow each other, and the third vector, which is the third side of the triangle, which completes the triangle, is the resultant vector. So put in mind, the triangle law and then the parallelogram law are used interchangeably. Sometimes you can use the triangle law, you can also use the parallelogram law. Even looking at the parallelogram law or the parallelogram, we see that it's made up of two triangles, which each of the triangles obey the triangle laws of vector addition. After getting your triangle laws or the parallelogram laws done, then you must apply another set of rules to solve your problem, to find solutions. Those rules are the sine rule and the cosine rule. And in the next video, I will talk about sine rule and cosine rule. Then we solve questions on that one. So thank you for joining this video. And don't forget, if you have questions or any concerns, don't forget to leave an email at learnwithmaki@gmail.com. Learnwithmaki@gmail.com. You can always leave us an email and tell us your problem, and we will help you with solutions. Thank you for joining this session, and we hope to see you in the next session.